Okay, now we will hook everything up to the sketchy projector, which will probably take a couple of breaks. So today's topic is files and a little bit of intro to file management. And hopefully I can find a YouTube video that explains file systems. It's intended for people that have no clue. If you're in that category, you might want to watch it at some point. If you have a clue, then this should be kind of somewhere between dull and boring. Press here to begin, press it again. Speak to the ballot for sure. Shirt used to fit me. So is everybody fixing to enjoy 3 days of cold weather? Sneezing, beautiful. Yeah, try to stay warm. Hope for snow days. Hope we get a snow day, which isn't as good as it used to be. Old snow days used to be you didn't come to school, nothing happened. Now we just do everything on home. That's okay too. For you in this class, your next class meeting is predetermined anyway, online on Blackboard. Okay, so my cat says hello to you all. And let's go ahead and fire up the lesson. See if I can get this out of the way. Stick it down there, and hopefully I don't need to use that lower left-hand corner. And I'm guessing that you don't want to do fluid mechanics, so let's get back to our class. Oh, I did make a mental note driving here this morning. I want to get to the last part of functions because I did not hit that with you all on Monday morning. And the last part I want to just briefly talk about is variable scope. So in a function, functions can have their own variables by design, and they are not accessible from the main program and vice versa. There's an exception to that. If we set a variable as global in a function, then the calling program and the function program can both change its contents. Usually one tries to avoid that. Occasionally there's no choice. Occasionally you have to do that. So keep that in mind as you're naming variables and dealing with a function. Don't globalize them unless there's a good reason to. I don't have any examples of that. The other thing that seemed to be challenging in the afternoon lab on Monday was dealing with creating a function, saving it to a file, and then importing that file. Because there was a lot of I did what you did and it didn't work. Well, if it didn't work, it means you didn't do what I did. So creating a function is just typing stuff into a code cell. So y'all can do that. That's not a problem. If for some reason I want to use that in the future, I would save that function in a you can get a who's in what's it going. Oh, come on, Amazon. As much money as you charge me per month, you should work. They charge me $12 a month to make all this stuff work, so it's really not fair on my part, but I feel like to complain about it because I have learned that complaining is something that we do best. So here, oh, actually, this is the actual example. So here's the Nico function that we had in lab and should have been in this class on Monday, but I was babbling too much. So there's a wrapper to the Nico function. Let me go ahead and run that block. And sure enough, I get this error message. It says there's no module named my library. This is my current, this is my current file system that script is trying to access. So if I look in that file system, Indeed, it is correct. There is no file, there is no module named My Library. So how would I create that? Well, I would go to, let's see, File, New File, and I need a Python file. So now there's a file called untitled.py. We'll leave the name alone for the time being. Let me go ahead and save the file so that black dot goes away. Really get my face out of the way. That's just creepy. Okay, so we still don't have a file named My Library. So let me take my untitled.python empty file, and I'm now going to type code into it, although I'm actually going to cheat. I'm just going to cut and paste, because I can cut and paste way faster than I can type, as can any of us in this room. Copy. Paste. And now I've got to fix some issues because that needs to go all the way to the left. So now I've got my spacing correct. So there's my Nico function. What does the Nico function do? It takes some input. The name of that input, as far as the function is concerned, is, read it back to me. Someone up front who can see. What goes into the Nico function? What is its local variable called that accepts input? Input argument, correct, that's the name of it. And then it imports the math subsystem. Then we have a local variable within the function called local variable that takes input argument and multiplies it by the square root of the absolute value of 1 plus the input argument. And then it returns the local variable back to whatever called the function. So let me save that, go back to my untitled thing and say, okay, good, I got my Nico function. Run it again and I still get the error. Let's make a slight change in the library name, Untitled. I'll change it back. So if I import untitled, it should go to that untitled.python script and load in all that code into the kernels. I'm hoping that happens and I don't get a different pink box. If I do get a different pink box, I'll get the names corrected. So I do that and all of a sudden the Nico function is working. And if you recall, the Nico function of 0 was short-term memory test. It's a 3-day-old memory, so that may be the long term. It should return a 0. It still doesn't work because I'm calling the external module by its wrong name. So what should I replace my library with? Untitled. Untitled will do the job. Let a rip, hit it with 0. Yay. Okay, I suggest you do not name your external modules untitled. That would be a monumental act of dumbness. And we want to avoid acts of dumbness. We have plenty of other opportunities to make them in the future. So any questions on that? I know that was very rapid. Hopefully it's being recorded. That will be of assistance to you doing homeworks. And we blew by recursion. A function can call itself. This is a fairly advanced technique, and for this class, especially if you're new to this stuff, avoid it initially. Later on, perhaps a year or two from now, you'll find it very useful. But in a recursive, a function that uses recursion has to have a base case. It has to have some sort of definition of what happens on its first entry. And then it can recurse on itself. If it doesn't do that, you sometimes lose control of the kernel and you have to go ahead and stop everything and try to repair it. And then the last part, this was to be presented without a whole lot of explanation. So here is a script that draws a picture. That's all that's supposed to be there. And so we're importing an external library without any explanation involved. And all the plotting material is already there. You're not supposed to change anything. And it makes this plot. And then we're going to take that external package and wrap it within a function called plot a line, because we have no naming intelligence whatsoever. And that plot a line takes a list 1 and a list 2, a string for the x-axis label, a string for the y-axis label, a string for the title, and it does all this stuff. And again, we don't have to do anything, just copy it and use it. So let's go ahead and do that. I think this will work directly. So if I copy that, put it into my script, run it, I've just defined the plot a line function. I don't have any errors yet, and so I'm going to assume it's actually going to get the math plot library subsystem correctly. And now we're going to put in our wrapper script. So the wrapper script is going to access plot a line. What it's going to do, we have two objects here. Years is what kind of object? You have a test on Friday. That'll probably appear on the test. Years is what kind of object? It's a list. How about GDP? It's also a list. Years is, looks like it's in decade intervals. Probably the individual elements are integers, but that's irrelevant. Oh, we're actually going to find out what they are in a moment. Then the plot aligned function is going to take years and put it on the x-axis, the left-right axis, and take GDP and put it on the y-axis, the up-down axis. And we're going to label the x-axis with the word year, the up-down axis with the word billions of dollars, and the plot title nominal GDP. Oh, it didn't work. Hate it when that happens. Oh, there we go. And we just drew our plot. So at this point, that's all the plotting and function stuff you'll need for, you have two homework assignments. Well, you have a homework assignment that involves essentially what I just did there, except with different lists. All right, so that brings us up to today. So instead of conjunction, junction, what's your function? We will go to files. Okay, so rapidly, and I have no bad puns to make because I need to catch things up. Our objectives today are to refresh your understanding of files, file types, search paths, demonstrate creating a file, deleting a file, opening and reading from a file, opening and writing to a file in core Python. Ultimately, you won't do much of that week after next because we'll have other tools that do a lot of file manipulation on our behalf. But occasionally you will download other people's packages, and that's okay. So a file system is a name that refers to how all the files are stored on your computer. They mostly look kind of similar. So if it's a Windows operating system or Macintosh or Linux or even real Unix, or even forget what the name of the DEC Digital Equipment Corporation. IBM. They all are structured pretty much the same. The individual paths and the various delimiters change from machine to machine. So here's a picture. Probably you can't even see it. So let me see if I can make this bigger. You know what word I was calling my machine, don't you? Let's see if that worked. Okay, that's what I wanted to achieve. Here's a picture of my Macintosh in my office. I don't know, whenever I need this. Okay. So the Macintosh filing system, you have options of how to display it. This is equivalent to File Explorer in Windows. And for me personally, I find it handy to have things in columns. And so my root of this particular picture is my desktop. And I'm going into, this happens to be commander.tpu.edu is a directory, or it's a tree a branch off the root. And in that directory, I'm in the 06977 data archive copy, final report, source, and there's actually more off to the right. And if we go down to the bottom, this reports the path to wherever I'm at. So I'm on Macintosh hard drive. That's my root directory. I don't know what they're called in Windows. It has an equivalent, but it's whatever Windows is. In users, my name is Theodore. I'm on my desktop, commander.ttu 5977 file report source. And if I actually had identified a file, there'd be a file name at the end. That whole list, not Python list of words, collectively is called the path. It is the path to a file. So I could have two files with identical names. myfile.txt, myfile.txt. But if they reside in different directories, they have the same name. So initially, human being, oh, that's got to be the same file. But the actual file name is the whole path. So myfile.txt might have 300 characters in its file name. It'll have the root directory, it'll be a slash, users directory a slash, Theodore a slash, desktop a slash, at commander.txt a slash, 06977 dataverse archive copy a slash, final report slash, source slash, myfile.txt. So that whole thing is the actual file name. That's called an absolute file name. If we happen to be in the directory where the file resides, and on my machine it's PWD is present working directory. If I happen to be there, I can refer to the file just by its name. But if I'm somewhere else in my operating system, in my file system, and I want to access that particular file, I have to use the absolute path to the file. Here's the equivalent in a bash shell, assuming it will let me scroll down. So there is the absolute file, or the absolute path, and this happens to be the directory of that particular path. So let's do readme.txt as an example. So if that's the file I'm interested in, its absolute file name is Macintosh hard drive, users Theodore, desktop at commander.txt 6977, final report, source, readme.txt. So your Windows file system is essentially the same. Some of the characters and delimiters are different. So the path is the general form or name of a file, and it specifies the unique location of that file on your file system. If you wanted to access that file on your computer, could you? Technically, you can't, because it's not even on your file system. I could establish a way for you to connect to my computer in my office and mount Macintosh.hard drive to your computer, and you could access the file at that point, but you would have to know the path to the file. So the path in a file system is the directory tree hierarchy in a string of characters with the path components separated by a delimiting character. The usual delimiting character is the slash, backslash, or colon, operating system dependent, although some systems might use a different delimiter, and paths are used extensively in computing. So if this is old stuff to you, that's fine. If you've never heard this before, this is going to plague you the rest of your time at Texas Tech and possibly the rest of your working career. Eventually you'll get it. Or you'll go to business school and then you can hire people to get it. So for example, let's suppose I have a file named guest.conf. So guest.conf is a file name. And if I were to refer to that file, and let's suppose my file system had these two paths, users Theodore, myget, at atomic kitty, hurry sensors, get, guest.conf, and Etsy Apache 2 users guest.conf. It's two different files. If I needed to access the file that's in the Git directory, I would have to give it that whole path. So I need to access the file that's in my Apache 2 users directory, which, by the way, I was just making that up. I do not have an Apache 2 users on my computer. I would have to use the entire path. So any confusion with that? So I'm seeing some grins, so this is old school for some of you. Okay, there are several types of files. Ones that we are often familiar with are text files or ASCII. So that Python file, which had the Nico function in it, is a text file. It happens to have extension .py. The operating system is told to associate that with Python subsystem. .txt is a common extension for text files. How about your Python notebooks, IPYNB? Are those text files? 50-50 chance. They are. They are ASCII files. If you look at them in a text editor, you won't. I mean, you'll recognize characters and stuff. You may not be able to interpret them, but they're a text file. Another type of file is a binary file. Text files are binary, but we'll just dispense with that mind screwage for the moment. Are binary files. They're regular files that have information readable by the computer. They might be executables. They might be configuration files. Normally, if we attempt to open a binary file in a text editor, it will identify this is a binary file. You sure you want to try to open it? And of course, you go, of course I'm sure. I know what I'm doing. You hit yes, and you get what appears to be gibberish. So you get funny looking characters. We'll go find one on my computer in a minute. The last type are directory files, and they may either be binary or text, but their purpose in life is to keep track of where files are. So they contain the metadata that your operating system and file management system needs to be able to find a file on those long ass paths that I just showed you. It's somewhere in the journal entry, which are these directory files. It has an inode number, and again, that's way beyond the scope of this class. That actually has the machine location of where the file starts. So if you have your stuff damaged by some Russian hacker, assuming there's not too much physical damage to your storage device, editing skills can find the inode of where the file is and reconstruct your file system. They will charge you a lot of money to do that, so it better be worth it. It's a lot of work. It's one of those few things where there's actually human work. Okay, so we'll examine just a handful of file manipulations. I said I was going to show you a binary file, so how am I for time? I'm good. So let me see if I can find one on my computer. Bring up a terminal window, make it big enough to see. Okay, so let's find a binary file. Well, we'll look at junk.r. So I'm going to use a filter called the less filter. I'm pretty sure junk.r likely we'll know in a second. That's an ASCII file. So it's got characters in it, humanly readable stuff. You may not know what any of that stuff is, but you see velo square bracket of I is clearly some kind of character string. Discharge divided by top width divided by depth. Okay, so now I need to find a binary file that's easy to find. I have system files in here. It's a directory. Oh, VIM info. That might be a binary file. It's big. It has a weird name, so that is not a binary file. That's an ASCII file. I will spend too much time trying to find one. My operating system, as yours is riddled with them, but you can never find anything when you need to, especially in front of an audience. If it was a binary file, it would say it looks like this is a binary file. Actually, I have a bash script. See if I have any that is change password. That is ASCII. That's a bash script. I could try a ISO image. It would tell me it's a binary file, and when I try to list it with a less filter, it'll mostly be weird looking symbols, and there'll be an occasional humanly readable symbol, and that's how you know it's a binary file. If you actually want to look at what's in a binary file, you need to use one tool is a hex editor. You can download those in the case of a Macintosh or Linux. They're built into the operating. You have to download them or activate them. Okay, so files. So if the file is completely unreadable in a language known as gibberish or mumbo jumbo, whichever of the two, and all you see is an occasional humanly readable character, it's probably a binary file. And at that point, you're doomed. You have to figure out what program is needed to read it. So let's go ahead and look at some file manipulations. So I am going to do this on my computer, which happens to be the Linux operating system. This will be, for Macintosh people, this should work unchanged for you. For Windows people, you'll have to change the script elements to the Windows equivalent command, which are stored on the mighty internet. So I'm going to import a package called system. And what the system package lets me do on my computer is actually directly access the operating system. So it's like sending commands to the operating system as if you were in a command or a terminal window. So I'm going to do rm-rf, my first file.txt. That's basically going to wipe the file if it's there, and I don't think it's there. And then I'm going to list my present working directory, and we'll list the contents of the file. So we're going to essentially see all this stuff right here. So when I execute that, it tells me that I am located on a computer somewhere. I didn't list the host name. Host name, I think, is atomickitty.aws. It's Amazon Web Services. So I'm at home, Sensei, Engineering 1330 web root. There's a total of 660 indexed files in that particular directory. Lessons, homework, readings, exam problems, and so forth, and course outline, Untitled Python. So that's my file system, or that's this directory in the file system. Now I want to, and here are what I think are the Windows equivalent commands. So I don't use Windows very often, as you probably have deduced. So when I do Windows equivalent commands, I tend to mess stuff up. But between these and the, so we did the contents of, so now we're going to create a file. So I'm going to create a file, and I'll do this in the script. And what I'm going to do is I'm going to use the open function that comes in Python core, and I'm going to give the file a name. I'm going to use the write symbol to tell it I'm going to write to the file, and then I'll put something in the file, and then I'll close it. So copy that, paste. Let's look at that before actually execute. It should work. So the key point here is notice that we open a connection to the file. You got to think of it as a connection because the file doesn't exist. We're creating a connection in the kernel to the file system. We're stipulating that we're going to write to the file. So if the file does not exist, it'll create it for us. If the file does exist, it opens the connection and puts the pointer at the top of the file, and then the writes will just clobber whatever in it. We do the write, and then when we're done, we close the file. Forgetting to close the file is a very popular way to make your scripts fail. and get stuck. So open, do the file activity, close. Let's go ahead and let it rip, see what happens. Sweet. It created a file called My First File. In My First File, it has the contents, message in a bottle. Must have been listening to bad radio when I did that. And we can look at the contents the way I just did by clicking on the file, or we can actually send a system command and have it show us what's in the file. Message in the bottle. Okay, now let's continue. Instead of writing to the file, so the file exists now. We're going to read from it. So the indication that you want to do reading is the letter R, W for write, R for read, A for append, and I think there's one that does some destructive reading. We're going to open our file, create the connection. We're going to read from the file whatever's in it as a single string, so it could be millions of characters long. I don't know what the upper limit of that is. It's big. We're going to put it into a variable named silly_string. Then we'll close the file, close the connection. And then we're going to print the contents of silly string. So what should be in silly string? It's kind of up there on the screen. So we should get a message in a bottle back. Copy. Paste. Sure enough, we get our message in a bottle back. And let's mess with our first file. Let's just add a second line. What do you want? What do you want me to type? Keep it short because I can't type for crap. Crap. Crap and nails. It's the name of my hardware store, okay? Crap and nails. We sell kitty litter and nails, and I guess we need hammers too. Because if your only solution's a nail, then every problem's got to be a hammer. So we've just changed the contents of the file external to our script. So let's go ahead and read it again. So what I'm expecting to get back is message in a bottle, crap and nails and hammers. And sure enough. So that's how we read from a file, and we saw how to write to a file. Now, the whole point of Jupyter Notebook is that you're not going into the operating system and doing what I just did, but I wanted to show you that the file can be changed in your script, or it can be changed externally, and that's something you need to be aware of later on. Okay, so the first two examples were supremely simple, but they illustrate the important points. We established a connection to the file. Once we have the connection, then we can read from or write to the file. And then we close the connection. The purpose of closing the connection is if that string was really long, let's say it was like first 100 pages of War and Peace by Leo Tolstoy. That's a lot of characters. Pretty much you have 3,500 characters per page on an ordinary book. First 100 of them is 35,000. The computer buffer is trying to read everything. If you don't close the connection, there might be characters left in the buffer that have never got to the file yet, and so they're lost forever. Because our computer garbage collection, one of the things in garbage collection is just to destroy stuff so you can reuse it. So we'll do the message. We'll attempt to write without a connection, and we'll get an error message. So this may happen to you all in lab or in homework, so you might as well see it here first. So let's suppose we have a file. We think we have a connection to an external file. I should be disconnected from it, so I should get that. So the error message, input-output operation on a closed file. It's smart enough to know that we've attempted to do an input-output and we don't have a connection to a file. The fix for that is to establish the connection. Open file name, read or write, whatever we're going to do. And now that was attempting to write. Now let's attempt to read from the file, still without the open connection. And I'll put it in a new window, let it rip, same error. Input output operation on a closed file. So how do we fix our first case? We open the file. So we'll use that command. We will open the file with a write opening. Now remember, there's already a message in the bottle, and we have crap and nails and snails and hammers. So now we'll open the file and write the contents to the file. So we've done that. Let's go see what's in the file. I think I need to close it and refresh it. Oh, I destroyed my file. Good job. And let's print the contents. My message. Actually, I'll just leave it be. We'll do the same. Let me close the file so it actually empties the buffer. That actually was an unintended good example of, by not closing it, it didn't push all the characters into the file yet. So now we will push the characters in the file. Still appears to be blank, but I think if I rewrite it, the closing is what pushed message in a bottle into the file. So if we were to attempt to read from it without establishing the read connection, we get this error here. So to read from the file, we have to make the connection, read, print it, and we can close the connection whenever we feel like it. I think I want to close the connection just before we print it. So closing the connection assures that all the characters that can be moved are moved from the file to the program and vice versa. So that's one way to think of it. The other way to think of it is just close it so that it works right. And we got our message in a bottle back. Yes. Yeah, we can do that. That's beyond today. So if you can remember that, we'll get an example. I think that's the important part. Now, if we want to update the contents of a file in 3 minutes or less, the keyword is our friend append, except not when I do that because it wants to scroll up. So we have writing to a file, the letters W. I actually think you could put the whole word write in that location and it would accomplish the same thing, but I'm not going to test that conjecture. Reading is read, and appending is append, or the symbol A. So here we're going to open a file, we'll create a connection to it, and we're going to add a new line character in the write statement, and then we'll put I love rock and roll, the waiting is the hardest part, and then we'll put some numbers in it, we'll close the file, and then we'll look at what's in it. So let me copy that. Paste, run it. So I've put a lot of content in the file. We can go look at the file this way. So it contains message in a bottle. I heart rock and roll. Put another dime in the jukebox, baby. And I can't remember which rock and roll artist that was in my intoxicants we did when we were. Waiting in the hardest part is Tom Petty, 1, 2, 3, 4, 5. And you notice there's this 6th line here. So I think I printed okay, there's the number list once. Oh, So that sixth line is a consequence of that new line character that was surreptitiously placed in that last write statement. All right, let's go back to our example and let's see what this next step does. So you've seen what the file looks like. If we do another script block, we're now going to open the file again, and then we're going to append to it a new line character, and we'll write that "I love rock and roll" line one more time. So when I do that, close my file, we'll go look at the contents again. And we've got that new line, and you notice there's also an extra line here because we had that dangling new line character surreptitiously placed in the write statement right there in the string literal. To delete a file, it can be done directly from the program, either using the system package or the operating system package. For me, I tend to use the system package because it just makes sense to me. And so I would remove the file recursively. The F means force the removal. Find my file.txt and delete it if it exists. The alternative is to import the operating system. The OS one will work regardless of Windows, Mac, Linux. And you invoke the operating system package and you choose the remove function and you tell it what to remove. They both have the same effect. Be really careful when you do that from within a script because a few characters in the wrong place can damage your file system in ways you don't want to. It's almost like letting me touch your computer. If you were in the afternoon class, you would know not to let me get near your computer because they would correctly bring it up to me, and because everybody's computer is different, I end up wiping out entire directories. I think I took out a semester of notes on somebody. Yeah, don't ever let me touch your machine again without an external keyboard and mouse. So another way to delete the file is shown here, and I would suggest the try except structure. So we're importing the operating system. We'll go ahead and we'll identify a file to kill, and then we'll attempt to remove it. And if that fails, we pass, and then I'm sending a message back to myself. So I'm going to kill my first file.txt this way. Close that. Well, I am deleting the file. God, I hope this doesn't break anything. And it now says the file is missing or deleted. Where is the rest? So it tells the file to kill, and it says it's missing or deleted, and it has disappeared from the file system as it is supposed to. So while that is an elaborate way to remove a file, that'll work. Here's some discussion on some two cryptic statements that are in the example. It's a way of printing the contents of numeric lists and exercising some control over that. And here's just a couple of other examples. And then to get to the question that the gentleman in the back had on how to read line by line, it's done right here. So that would be how you would do it line by line. You'll get a practice of that in the lab. So that's all I have for you this morning. I will see you in presumably 8 minutes, 8 to 10 minutes for the lab. Thank you for your attention and putting up with bad jokes.
I don't know if you can mark me my name down in assistant list. I've been a little bit late.